batteries. There's something that with modern day technology we cannot live without. Our smartphone devices, medical devices, your computers, your scanner radio, which is why we're talking about them today. We'll go through an introduction of batteries coming up right now on Scanner School.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome to Scanner School. My name is Phil Lichtenberger. My amateur radio call sign is W2LIE. And this is session number 40 of the Scanner School podcast. If you want to get any of the show notes, we're going to be talking about a lot of stuff this week, so show notes might be a good thing. You can go to scannerschool.com/session40. That's the number 40. And from there, you can get all the show notes and the links for things that we have talked about on today's podcast. Now, again, we're going to talk about a lot of little acronyms and kind of things like that. So session show notes may actually help you out here. And before we get started, too, I just want to remind you, if you're listening to the podcast right now on a smartphone or a player device, take the device out of your pocket, click subscribe. That will ensure that next week's podcast and all future podcasts are automatically delivered right to your device as they are published weekly. If you still like listening on the computer, no shame in that. There's plenty of podcasts where I listen to on the computer myself. Just go right into our email list. Right in the homepage, there's a subscribe button for our email newsletter. And in that email newsletter, we talk about, we keep you remind you of what's coming up on the podcast, what we've done, and anything else that might be behind the scenes that we don't talk about on the podcast, exclusive to those on the email newsletter. So go to scannerschool.com and look for the little email sign-up form. And before we get into the meat and potatoes here, I want to remind you all that there's a contest running right now on East Coast Pagers. Now, full disclosure, East Coast Pagers is one of my online companies. And it's what East Coast Pagers is what basically is the financial backing of Scanner School, which is why every week Scanner School is brought to you by East Coast Pagers. So here's the deal. Until the end of this week, if you're listening to this podcast live as it comes out, you have just a couple of days to either enter daily or sign up for the first time. EastCoastPagers.com/contest for your chance to win a $100 East Coast Pagers gift card. This gift card is good for anything we sell on East Coast Pagers. So if you're looking for a new Unication G1, G4, G5 pager, you want a Swiss phone pager, check out the new S-Quad 360. Maybe you already have a pager and you're looking for a programmer kit, an amplified charger, or just a couple of cases. $100 for any accessory or any page that we sell on East Coast Pagers. Now, just keep in mind that East Coast Pagers is authorized to do business in the continental United States. So unfortunately, if you're international, you can still participate. I just can't ship you anything. So again, eastcoastpagers.com/contest. And this contest expires at the end of this week, September 29th, 2018. Winner will be held on Sunday the 30th. So best of luck. And again, East Coast Pagers is what keeps Scanner School going. It's all the sales I make over there that I'm able to hire out my help and pay for hosting and all the other stuff that it takes to keep Scanner School afloat. Now, if you want to help keep Scanner School afloat, you can do so easily by going to scannerschool.com/support. We got a couple of great ways that you can do so. We'll talk about them more at the end of the podcast. But right now, before we go any further with anything else like that, I want to get into what we're here to talk about: batteries. So on last week's podcast, we talked about a simple and easy battery backup solution. I forget the exact name or title of the podcast, but in session 39, scannerschool.com/session39, you can go get all the show notes there. I talked about how I have a battery wired into my scanner radio setup in addition to the 12-volt power supply. And after recording that episode, and sorry if it sounded a bit hurried, but I left out a little bit on batteries, and I listened to it and I thought to myself, you know what, maybe I should really talk about, what batteries, the different kinds of batteries, and get into a little bit deeper on that one. So we're going to talk about that. We're not going to go into every type of battery out there, because that's just not what we're here for. We're not here to get into the chemical breakdown. We're not here to get into, all the inside stuff of the battery. No, we're here to give you an introduction on it. The basic terms, the basic, types that we use, that we have our hands on a daily basis, why we use certain types and what we don't. So it's going to be a very high level, 30,000-foot view, which is my favorite view on looking at things, especially when it comes to a podcast on batteries and stuff like that. So basically, what is a battery? Well, a battery is a device that obviously we're all familiar with. We have them basically in our pockets right now. Hearing aids, medical devices like pacemakers, our computers, like we said at the intro and the top of this. But batteries is what makes everything around us basically work, right? So inside the battery, there's a little bit of a chemical reaction going on there. And that little chemical reaction creates a voltage. It's a chemical energy that becomes an electrical energy. And what ends up happening is when you hook up to the positive and negative terminals on a battery, you create a circuit. And it's that circuit that allows the chemical reactions to start taking place, and that creates the voltage. So again, batteries have two terminals. There's a positive side and a negative side, right? The positive side is the plus side. The negative side is the minus side of a battery. So voltages are another key thing on batteries as well. You'll see that batteries are rated in voltage. Sometimes that you're very familiar with is a car battery. Here in the States, 12 volts. All batteries are DC or direct current, by the way. And AA batteries, AAA batteries, C cell, D cell batteries are 1.2 volts of voltage. You can see, though, larger battery sizes, 3.6 is a common battery voltage when it comes to like watch batteries or lithium ion batteries and stuff like that. So the other measurement we use when it comes to batteries is the ampere hours. Sometimes it's labeled on the battery as milliamp hours, but basically it's the amp hours is the amount of energy charge in the battery that will allow 1 ampere of current to flow in 1 hour. So ampere hours, milliampere hours. What you want to look at, though, is there's 1,000 milliamps in an amp. Okay, milli is 1,000 level of the ampere. What you want to find out, though, is what the current draw is on the piece of equipment you're going to use. So if you have something that requires 7 amps or 10 amps, you'll see how much that divides into the milliampere equation. So to use the example that we had last week when we talked about the 12 volt 7 ampere hour sealed battery we use for our backup system here, basically it's battery life equals ampere hours divided by your current, or amps. So let's assume for our scanner, using the same example from last week. So if you listen to last week's podcast, this is all very familiar to you. A scanner takes, in theory here, right? It doesn't normally take an amp, but we're going to just say for the sake of calculations here that a scanner or whatever it is you have hooked up to your battery takes an amp. If the battery capacity is 7 ampere hours, your scanner pulls an amp, then your battery should last about 7 hours. Again, that's in a perfect situation. That's if there's no loss in lines, the battery's completely healthy, that, there's no corrosion. Perfect situation here. So we have two basic kinds of battery types. We have the non-rechargeable battery type, and we have the rechargeable battery type. So non-rechargeable batteries cannot be recharged, as the name says right there on the side of the tin. The chemical reactions that take place inside of the battery are non-reversible. It means you can't go back and replenish the battery, because whatever happens inside there, when a chemical chain of events happens that creates the voltage energy, you can't replenish that. It's gone. So if you were to try and recharge a non-rechargeable battery, you could, blow up the battery. Basically, it would just self-destruct, or it could self-destruct. Now, a very common type of non-rechargeable batteries, an alkaline battery. We kind of see them on Energizer, Duracell, off-the-shelf batteries that we typically buy from the home improvement centers and our local drugstores and everywhere else that sells non-rechargeable batteries. Rechargeable batteries come in various forms. I mean, there's half a dozen plus to a dozen types of rechargeable batteries out there. And if you really want to go through it, we'll put a link to it in the show notes where you can find out more. But we're only going to talk about the ones that are very common here. So, but unlike non-rechargeable batteries, rechargeable batteries can have their chemical reactions reversed by recharging them. So we have a couple of different kinds. We have a wet cell and a dry cell when it comes to rechargeable. So a wet cell is also called a flooded cell. It basically has liquid inside of them, and they are vented so that the gases produced by the chemical reaction can escape out into the atmosphere. One common type of wet cell is a lead-acid battery, and they were designed for a deep discharge. So they're really great for an environment where, you might have an emergency power situation like, cell sites or a radio tower or something like that is not on household power and may not regain power after a power outage for quite some time, and the batteries will be completely depleted by the draw that's required. So it's basically has a liquid electrolyte inside of them, and they must be oriented in a set direction so that none of the internal chemicals will spill out. Now, the exact opposite of that is a dry cell, which uses a paste for the electrolyte instead of the liquid. They are sealed, so they don't need to be kept in a certain position. It can be stored in any orientation. What's one common type that we're very familiar with is a lead acid. Dry lead acid is found in automobile batteries. 12-volt automobile batteries, maybe the batteries that are found in UPSs or uninterruptible power supplies. Again, that is tripping me up from last week. And also can be manufactured for starter batteries, deep cycle batteries. So again, stuff that would start a car or an engine would be used for a lead acid. So let's talk about stuff that we are very familiar with when it comes to our radios. Some of us who are in the hobby longer than others might remember the old NiCad battery or the nickel cadmium battery. Basically, it's Ni, or capital N, lowercase I, capital C, lowercase d, NiCad. So it's made with a nickel oxide hydroxide and metallic cadmium as electrodes. Normally, a NiCad battery cell is 1.2 volts, which is exactly the same as an alkaline battery. And you can find NiCad batteries in all the standard alkaline battery sizes, AAAs, A's, C's, D's, you name it. Basically, there's a 9-volt battery, right? It could all be NiCad batteries. And they were widely produced, widely used, and they were replaced by the cheaper nickel metal hydride battery. So NiCad batteries would also suffer from the memory effect. If a battery was charged and then reapplied to charge at a certain point, or the same voltages over and over again, the battery starts to remember what its full state was and then when it started to need to charge. So at a certain part in a discharge cycle, the battery would get to that tipping point and then rapidly discharge itself and drop in voltage. So devices would kind of realize that, well, the battery just dropped in voltage, and it would appear that the battery was dead. Even though the battery wasn't dead, it just dropped below the usable voltage that your equipment could operate at. The battery would basically sit at 1.2 volts, and it would slowly drop. Then it would get to a certain point where it would just go boom, off the cliff. So its life would be cut short. Then you would charge it up again, and then you would reinforce the memory effect of the NiCad battery. Well, again, like I said earlier, the NiCad battery was replaced by the nickel metal hydride battery, which is NiMH, or capital N, lowercase I, capital M, lowercase h. Now, the typical cells on a nickel metal hydride battery is 1.4 to 1.6 volts, and it's pretty much replaced the NiCad market. You can charge up nickel metal hydride batteries in a quick charger. You can trickle charge them. They don't suffer from the same memory effect. And again, just like NiCad batteries, they are available in all the standard sizes: AAA, AA, C cell, D cell, 9-volt, and whatnot. So there's one final one that I want to talk about today that's a pretty common one. And these are the ones that kind of have a bad rap as of late. These are the lithium ion batteries, shortened by Li-ion. Now, these are extremely popular in smartphones, portable electronic devices, two-way radios, and now Uniden is shipping a lithium-ion battery in the SDS 100. Now, lithium-ion batteries are basically packages of cells, so they are a battery pack and not so much an individual cell that you can go out and purchase. So you're not going to find lithium-ion batteries in popular battery sizes like AA, AAA, C and D. So what makes a lithium-ion battery a little bit different is that lithium ions move across the positive and negative electrodes, and they have a very small memory effect, right? And they have a very low self-discharge rate, where nickel metal hydride self-discharges from various rates from 5 to 20%, depending on the time of the charge and temperature. Lithium ions are about 1.5 to 2% per month. So you can see why, again, too, lithium-ion batteries are becoming very popular, because they have a very well shelf life, and they tend to last longer, but they can also be a safety hazard should they overheat, become overcharged, or shorted out, they go through what's considered like a thermal runaway. And that's where you see all these pictures where the batteries are exploding, or they start smoking, or they catch fire. People get injured because something inside the battery just goes through a thermal runaway. And those batteries probably didn't have a safety trigger inside to basically, disconnect the batteries when that should happen. A lot of nickel metal hydride batteries do have a safety device that will cut off the batteries should something happen like that. So another thing we didn't talk about real quick either was that you can't use a nickel metal hydride charger to charge a lithium ion battery, right? They are different types of internal structures, and they should each be respected when it comes to using them properly, even when it comes to disposing of the battery, right? There's a lot of chemicals in there, and you shouldn't just go ahead and toss them and throw them in a landfill. All right, so that's a quick primer on batteries. I didn't want to bore anybody, get into all the specifics. There's a lot more batteries out that we talk about. But again, just for what we use here, typically, we didn't go into the sealed, the AGM, or the gel cells. I mean, you could talk about those on a more detailed level, or I'll catch up on them on the blog post or something like that. But again, I wanted to really talk about what it was that we use on a daily, day-to-day basis, especially when it comes to the scanning hobby, right? We're all pretty much familiar with nickel metal hydride, NiCad, and lithium ion, and that's really where I want to spend the most of my time talking about. So what is it that I use here in the shack? Well, I use a lot of lithium ion when it comes to the devices that come with lithium ion, like my Unication G5 devices have a lithium ion pack. The STS-100, lithium ion pack. And Uniden, if you're listening, I'm still waiting for my replacement battery pack. I still have the original skinny pack. But when it comes to, nickel metal hydrides, they're not all created equal either. Just because they have a rating on the side of it, you get these bargain basement batteries, and they don't really last as long as some of the higher quality ones. So one of the things I typically do is when I get a brand new radio, especially the ones that come from Uniden, even though they have a rating on it of 2,300 milliampere hours on it, I don't ever find that they last as long. So what I usually do is I toss those and I throw in a pair of Envelope or Tenergy rechargeable batteries. And even though they basically have the same amount milliampere hour rating, I just find they work a whole lot better. So if you're interested in looking at replacement batteries for your scanners, go ahead to, again, check out the show notes at scannerschool.com/SM40. I will put a link in there for you on the batteries. But again, too, if you're looking for Envelope or Tenergy batteries, just go to scannerschool.com/battery or scannerschool.com/batteries, and we'll take you off to an affiliate link where you can go ahead and purchase either Tenergy's or Envelope batteries. And also, if you use that link to purchase the batteries, you'll be helping to support the Scanner School podcast. Now, again, this comes at no cost to you, so it's a great way to help support the podcast. And if you're going out to making a purchase anyway, we'll earn a small affiliate link, which is what helps keep us going. Now, we also have Patreon. Now, Patreon is a great way to also help support the podcast on a pledge basis. So I want to thank Mark Beebe and N.T. Bono, Kenneth Fowler, and James Felling for helping support the Scanner School podcast with a monthly contribution. Now, you can also help support Scanner School for as little as $1 a month. And every dollar helps. It goes towards the hosting and everything else it is that we do here at Scanner School. So next week's podcast, we got a little bit something different going on. As I've been saying, I have been collecting emails and questions that have been coming in, and I haven't been able to answer them as quickly as I would like, and I am a little bit embarrassed and very sorry for anybody I've left hanging. But we have a pile of questions that need to be answered. So starting next week, we are going to be answering questions that have been submitted, whether they've been coming in through social media or through an email or through our voicemail hotlines. So if you want to get your question answered, the fastest way to do so and the way to jump the line is to go to scannerschool.com/ask. We have a button there for SpeakPipe, and you can submit your question, and we will insert your audio bite and play it on next week's podcast or a future podcast if we can't get the edit done in time. We also have a local telephone number here to the States if you want to do that. Again, that number is available at scannerschool.com/ask. So next week, we'll be answering some of your questions. We will make it a routine probably once a month thing. If we got a lot more questions, though, we'll expand that out and fill in some space that way as well. So my call to action for you right now is if you have a question that you'd like to have answered, go to scannerschool.com/ask. If you do it early enough, I can get it on next week's podcast and answer your question. All right, guys, that is it for now. Don't forget to subscribe to the podcast, and we'll catch you all next week. My name is Phil Lichtenberger. I want to say thank you so much for listening to the Scanner School podcast, where we teach you everything that you need to know about the scanner radio hobby. We'll catch you all next week, everyone. Thanks again.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.